Okay, so exams are right around the corner, and grade 8 math can sometimes feel like this impossible puzzle. But what if you had the perfect toolkit to solve it? Over the next few minutes, we're not just going to study math. We're going to build a set of tools that'll turn that confusion into total confidence. Let's dive in.
So be honest, does math ever feel like you're just trying to memorize a giant random list of rules that don't even connect with each other? Yeah, you're definitely not alone. It can feel completely overwhelming. But what if I told you there's a much smarter way to look at it?
So let's just throw out that whole idea of memorizing endless rules. Instead, I want you to imagine we're building a toolkit, a really powerful one. Every concept we cover today isn't some random fact to remember. It's a specific tool, perfectly designed for a specific kind of problem.
All right, let's open up this toolkit. First things first, we need the fundamental building blocks. We're talking about functions, which are basically the rules of the game, and algebra, which is how we play detective and find all the missing pieces.
First tool up is the function. The easiest way to think about this is like a recipe, or maybe a machine. You put something in, that's your input, and you get exactly one very specific thing out, that's your output, every single time. That consistency is what makes functions so incredibly important in math.
Now here's where it gets really powerful. A single rule, a single function, can be dressed up in a few different ways. The one you see most often is a formula, right? Something like y equals 2x plus 3. Think of this as the shorthand recipe. It's quick, it's efficient, and it tells you everything you need to know. But you can also show that exact same rule using a table of values. All this does is show the rule in action. For every x we decide to plug in, we can see exactly what y our little machine spits out. It's the same information, just laid out differently. And finally, we can just say it in plain English. Double the input and add 3. See? A formula, a table, and a simple sentence. There are 3 completely different ways of looking at the very same mathematical story. And being able to jump between these, that's a huge advantage on any test.
Okay, so if functions are the rules of the game, what happens when we're missing a piece of the puzzle? Well, that's when we pull out our next tool, algebra. Think of this as our detective kit. It's what we use when we know the rule and the final result, but we've got to work backward to find a missing clue.
And the master key in our detective kit is using inverse operations. You know, opposites. Think of an equation like a perfectly balanced scale. Whatever you do to one side, you have to do to the other. So to get our unknown variable all by itself, we just undo what's been done to it. We use subtraction to cancel out addition and division to cancel out multiplication. It's all about keeping things balanced.
So we've got our rules, and we've got our detective skills. Now let's add a tool that actually lets us see the math. This is where we take all those numbers and formulas and turn them into something visual, into a story we can see at a glance, with graphs.
And you know what? Drawing a graph for these functions is actually a pretty simple 3-step process. First, you make that table of values we talked about earlier. Second, you plop those pairs of numbers as little dots on your graph. And third, you just connect the dots with a nice straight line. That's it. Now here's a pro tip, and trust me, this seems small, but it makes a world of difference. Neatness really matters. Always use a ruler, and make sure the numbers on your axis go up by the same amount each time. A neat, consistent graph isn't just easier to read, it actually helps you avoid simple mistakes. Okay, so we've gotten really good at seeing math on a flat 2D page. Now, let's expand our toolkit into the 3D world, the world we actually live in. In this section, we're going to look at the tools for moving, changing, and understanding shapes.
Transformations, it sounds like a fancy word, but it just means rules for moving shapes around. We can slide them, flip them, or turn them. Take a reflection, which is just a flip. When you flip a shape over the x-axis, there's a simple rule. Every point's x value stays the same, but its y value becomes the opposite.
Now let's look at the shapes themselves. I want you to think of this table as your ultimate cheat sheet for the basic 3D objects. It tells you the number of flat faces, straight edges, and corners or vertices. Knowing these by heart is a game changer, so this is definitely one to commit to memory.
And get ready for a kind of mind-blowing math fact. In the entire universe of possible 3D shapes, there are only 5, just 5, perfectly symmetrical solids where every single face is an identical, regular polygon. They're called platonic solids. How wild is that?
So far, all our tools have been about finding definite, clear-cut answers. But the real world is messy, right? It's uncertain. So for the final tool in our kit, we're diving into the world of chance.
This is how math helps us look at possibilities and actually make educated guesses about the future.
Okay, the number one thing to get right here is the difference between two big ideas. On one hand, you have theoretical probability. That's what we expect to happen in a perfect world. You know, a 50-50 chance of getting heads on a coin flip. But then you have relative frequency. That's what actually happens when you do the experiment.
And this bar chart shows that difference perfectly. In theory, that coin should land on heads half the time, 50%. But in this real-world experiment with 50 flips, it actually came up heads 56% of the time. And here's the really cool part. The more times you flip that coin, the closer and closer your actual results will get to that perfect 50% theory.
And there you go. In just a few minutes, we built a complete, super powerful toolkit for your exam. We've got functions, algebra, graphs, shapes, and probability. You have all the tools. So let's do a quick fire review of the absolute key skills you need for each one.
So remember, for functions, be a quick change artist, switch between tables, rules, and words. For equations, always show your work and then check your answer. For graphs, be neat. Ruler and labels are your best friends. For transformations, you gotta know those coordinate rules cold. For 3D shapes, memorize those properties, faces, edges, vertices. And for probability, be super clear about the difference between theory and what actually happens. I want to leave you with this last thought. You have built the toolkit. You have the skills. So as you practice, remember this, every single mistake you make isn't a failure. It's just you getting better at using your tools. It's a step on the path to mastering this. Good luck. You've totally got this.